me see if I can borrow this picture here. If not, I will just draw another one. But we want to know now. See, I'm going to erase this picture here. And let me see if I can take this right here. Let me see. Home. See. No, okay, I'll just draw it. Okay, so I want to go ahead and find the reference angle for the given angles. Well, that's going to be pretty simple, guys. This is, after all of that we just shared, we're going to do this one right here. So a reference angle, that's why I wanted to borrow that picture, but I'll draw it here. All right, so a reference angle is basically an angle formed by the terminating ray, the ray that we're going to draw, and the closest part of the x-axis. That would be the reference angle. So just like on the other one that we were talking about, an angle in standard position, and we're looking for theta, it's the angle formed by the ray and the closest part of the x-axis. So a 300-degree angle, if you think about it, is going to go 90, 180, 270, and it's going to go right here, somewhere in this position right here. So that's where the angle is going to go, right there. Theta is going to be right here, the closest part to the axis. That's your reference angle. A reference angle is the angle formed, again, by the terminating ray and the closest part of the x-axis. Well, how many degrees more did we need to go to make the full 360? Because we went like this, right? Or for you guys, it's like this. So how many more degrees to get to the 360? Well, we need 60 degrees, right? 60. That's your reference angle because that's the angle that's closest to the x-axis. So the answer to A is 60 degrees. The reason that's important, guys, is because if I type in, for example, let's go back to the calculator. If I type in the sine of 30, by the way, that's going to be 1/2, or was it 60? Wait, I'm sorry. It was 60, right? 60 degrees, okay. The sine of 60. The sine of 60 has a decimal value of 0.866. If I type in the sine of, let's change the 60 to 300, which is the reference angle, you get the same thing, but negative, but you get the exact same thing. We'll talk about why is this one negative. We'll talk about that in a little bit, but at least the value is exactly the same. That's why reference angles are going to be very, very important to us. The reference angle is just the angle, it's 60 degrees. But if I ask you for the cosine of 30, and I ask you for the cosine of 330, which is 30 degrees away, it's the same value, okay? Because they refer to the same type of angle. It's just in a different quadrant. Okay, let's go to the next one. What is the reference angle for cosine of negative 2 pi over 3? Well, I think since we're more familiar with degrees, I think you want to change that to degrees. So you can go through the motions of changing it. I can already tell you the way I do it is I know that pi, the conversion value is 180 degrees. So I know pi is going to cancel, 180 is going to be there. So 2 times 180 divided by 3, what I do is I take the 180 and I divide it by 3 first, so that I make that into 60 degrees, and then multiply it by 2. So that's 120. Negative 120 degrees is really what they're doing. I do that mentally, of course, I have more experience with this, but I would do that as a student as well at some point. Once I figured, oh, pi is just half, a circle, 180. So it's 180 divided by 3 is 60. 60 times 2 is 12, 120. So that's negative 120. So a negative angle of 120 degrees means you go 90 and then maybe 30 more. So that means that, once again, I have a 60-degree angle. So 60 degrees is my reference angle. Again, the closest angle to the x-axis. So if I just, and again, I don't believe we actually needed to do the, I think on the reference angle is just 60, but if they wanted, I think I copied the instructions wrong, because the reference angle would just be 60 on each. But if they want radian, so this would be pi over 3. You need to convert that into radians. So my answer is pi over 3. So again, I was looking at why is cosine there? So I think I just copied that wrong. But the next part is going to ask you those things. What's the cosine of 120? What's the tangent? Okay, so here's the important thing. This is going to be a long video or 2-part video, guys, but Very, very important. If you can start memorizing these values, this is going to be super helpful if you can memorize. There are 9 values that I would like for you to memorize. The sine of 30 degrees, the sine of 30 degrees, if theta is 30, well, the sine of 30 is 1/2. The sine of 45 is the square root of 2 over 2. The sine of 60 degrees is the square root of 3 over 2. The tangent of 45 is 1. Like all these, you say, oh, is there more things to memorize? Now, you don't have to memorize it because you can actually draw a 30, 60, 90 triangle. But if you don't memorize them, you at least want to get really good at this. Draw a 30, 60, 90 triangle, and the 30, 60, 90 triangle is as simple as 1, 2, square root of 3. The 30, 60, 90 triangle is as simple as 1, 2, square root of 3. What does that mean? That the 30, 60, 90 triangle, when you draw it, put a 1 on the short leg, and I mentioned this before, put the 1 on the short leg, put a 2 on the hypotenuse, because the hypotenuse is twice as big as the short leg. This is from geometry, and I also mentioned it earlier when I introduced chapter 4. All right, so the hypotenuse is 2, and the middle side is the square root of 3. That was one of the combinations that I asked you to memorize, 1, 2, square root of 3. Just put them in the right place, though. The 1 to 2 ratio is from the short leg to the hypotenuse. The hypotenuse is twice as big, and the medium leg is the square root of 3. So the reason the sine of 30 degrees is 1/2 is because when you look at a 30-degree angle, you're looking at a 30, 60, 90 triangle where the opposite side is 1 and the hypotenuse is 2, 1/2. The reason the sine of 60 is the square root of 3 over 2 is because if you look at the 60-degree angle, opposite, square root of 3, hypotenuse 2. So that's where those numbers are coming from. Now, if you can memorize it, you'll avoid having to draw the picture, but if not, that's okay, you can draw the picture. In a 45, 45, 90 triangle, the ratios of the sides are 1, 1, radical 2. Remember, if you have 45 and 45 degrees, you have 2 equal angles, you have 2 equal sides. Those sides, the legs, are 1, and the hypotenuse is the square root of 2. So that's why, if you look at the sine of 45 degrees, the sine of 45 degrees is square root of 2 over 2. That's because now you're dealing with a 45, 45, 90 triangle where the sine is opposite leg 1 over the hypotenuse square root of 2. Now they have simplified it, 1 over the square root of 2. If you simplify that by multiplying by radical 2 top and bottom, you get the square root of 2 over 2. And that's why the sine of 45 is the square root of 2 over 2, because that is in simplest radical form. But if you just leave it as 1 over radical 2, it is exactly the same value, okay? All right, moving on. Find the exact value of the cosine of 120. See, this is where reference angles kick in. If I want to know the cosine of 120 degrees, well, 120 is going to be 90 plus 30 more, right? So it's going to be right here. So it looks like it's a 60-degree angle. That's the reference angle. So the cosine of 120 is the same thing as the cosine of 60. Well, the cosine of 60 is, if you go to the, over here to this triangle, the cosine of 60 is adjacent over hypotenuse, so 1 over 2. Or if you memorized it, cosine of 60, look, cosine of 60 is 1 over 2. It's 1/2. So that would be 1/2. Just be careful though, because in that quadrant, cosine is not going to be positive, because in that quadrant, if I draw it again here, theta is here, right? Here's theta. The adjacent leg, which is going to be this guy right here, is actually a negative x value. So this is actually negative 1/2. Now, this can get kind of tricky, and this is where kids make mistakes. So we came up with a little, I didn't come up with this, but through, many pre-cal teachers, cal teachers, come up with these mnemonic devices, these little tricks that can help you remember things. Did you know that did you know that advanced students take calculus? So I came up with that little statement there. Advanced students take calculus. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you go in the order of the quadrants, advanced students take calculus. That little device, that little mnemonic device, is going to help you remember that all functions are positive here. The sine, the cosine, the tangent. If they ever ask you for anything like the cosecant, the tangent, the cotangent, the sine, whatever, everything here is positive. All x values, all y values are positive. So if the angle ends up here in the first quadrant, all of the functions will be positive. However, if you are in this quadrant right here, now talking about the three main functions, the sine, the cosine, and the tangent. In this quadrant, if your angle ends up in the second quadrant, the sine function is positive. The sine, S means the sine is positive. So that means that the cosine and the tangent will be negative. Like in this one, it was cosine there, so I knew the answer was going to be negative. If the angle ends up in the third quadrant, well, that is the tangent quadrant. The tangent quadrant is, that means that an angle ends up in the fourth quadrant right here. That is the cosine quadrant. That is where an angle that ends up here, and if I'm asking you for cosine, then the cosine is positive. By the way, if I'm asking you for cosine, then the secant, which is the same numbers but flipped over, the secant would also be positive. So again, in this quadrant, quadrant 2, sine is positive, which means cosecant is positive also. In this quadrant, tangent is positive. So that means cotangent is also positive. In this quadrant, cosine is positive, which means secant is positive as well. All right, let's go to the next one. What is the exact value of the tangent of 7 pi over 6? Well, you might want to change that to degrees first so you can get a better idea. So I would say 180 divided by 6, 18 divided by 6 is 3, right? 30. 180 divided by 6 is 30, times 7 is 210. So 200, this is actually 210 degrees. So if you go 210, that's 90, 180, 210. That would be right there. So theta is here, which is actually just 30 degrees off that side right there. So the reference angle is 30 degrees. So the tangent of 10 is the same thing as the tangent of 30. And in that quadrant, remember, advanced students take calculus. In that quadrant, tangent is positive. Therefore, this is going to be a positive, whatever the tangent of 30 is. The tangent of 30 is the same thing as the tangent of 210, which is the tangent of 7 pi over 6. Now remember right here, the tangent of 30 is the square root of 3 over 3. So you can do it from there, or you can calculate it by drawing the picture. Either way, it is the square root of 3 over 3. That is my answer, and it's going to be positive. On the other one, I never highlighted it or circled it. There it is. That was the answer for that one. Again, pause, read. It says, if the tangent of theta is 5/12, where the sine is less than 0, where the sine theta is less than 0. Well, remember that advanced students take calculus. So if the sine of theta is less than 0, which means negative, right? Less than 0 means negative. Well, then I'm not talking about an angle that would be drawn in the first quadrant. Everything's positive there. Or in the second quadrant, because sine is positive there. It's either going to be in the third quadrant or the fourth quadrant. That's where sine is negative. But look at what it says. If the tangent of theta is 5/12, does it say negative 5/12? It doesn't say negative 5/12. It says positive 5/12, right? So that means that you use logic and you say, well, then it can't be the fourth quadrant. It's got to be the third quadrant. So it's a little like a puzzle here. So you're drawing theta in the third quadrant where the tangent is going to be 5/12, which means that the opposite leg is 5, the adjacent leg is 12. It's actually -5 and -12, and that's why it turns to positive. And if you do the Pythagorean theorem, the square root of 5 squared plus 12 squared, you're going to get 13 right here. Now, what is the cosine of theta there? Well, the cosine of theta would be the adjacent -12 over the hypotenuse 13. And that would be your answer. Okay? Let's do the next one. If the secant of theta is the square root of 3, so now, let me sketch this, and it is an ugly sketch, where tangent is negative, okay? Where tangent is negative, so it's not here, and it's not going to be here. Remember that advanced students take calculus. So if the tangent theta is negative, that means it can't be the first or third quadrant. It's got to be the second or fourth quadrant. But look, it says secant is the square root of 3, which means the cosine must be 1 over the square root of 3, like the reciprocal, right? So cosine is positive in the fourth quadrant, so it must not be here. So the picture that I'm drawing must be in here. This is theta, and then the adjacent must be 1, and the hypotenuse the square root of 3. And then you do your Pythagorean theorem, the square root of Square root of 3 squared minus 1 squared. So that's 3 minus 1, which is going to be the square root of 2. So there is your